Hello everyone, my name is James. Welcome to a brief tutorial on fundamental concepts of the MQTT messaging protocol. I'm really excited to show you where and how MQTT can be used in an IoT application. Thanks for joining me. Let's get started. Here are the topics we will cover. Before we delve into the details of what MQTT is all about, first we will look at the origin of MQTT in order to have some background information about why MQTT was created. Then we will start with a high-level overview of MQTT framework by focusing on some terminologies associated with these major elements, such as MQTT client, MQTT broker, and MQTT topic. Next, we will go on to message flows that takes place between MQTT client and MQTT broker. The message flows involve a sequence of steps that must be carried out to establish a connection before data can be sent out or received. Once we have a better understanding of how MQTT works, we will move on to some benefits that make MQTT the ideal messaging protocol for IoT applications. We will also look at some great features supported by the Antaira Industrial Cellular Gateway, which facilitate communication bridging among different types of IoT sensors. And lastly, I will get into a hands-on tutorial that demonstrates the use of MQTT in an IoT application for smart facility management. Let's start with the origin of MQTT. Before the creation of MQTT, the oil industries adopted for the proprietary solutions such as the SCADA polling and response protocol in order to monitor flow or control automated valves of the oil pipeline using satellite networks. During that time, there were some challenges of using the polling and response protocol over the satellite links. Let me give you some examples. Firstly, there was a natural delay between the time requesting and receiving the data due to the satellite's positions change, which resulted in timing gaps. The SCADA saw these timing gaps as error conditions because all these polling and response didn't happen in a preset time interval. Secondly, it wasn't feasible to expand capacity by adding more devices. Since the SCADA was already connected to the existing 4,000 devices, these devices were either pressure or temperature sensors or actuators mounted on the oil pipeline. When the SCADA tried polling all of these devices at once, the available bandwidth on the communication link between the satellite and the SCADA was saturated. The satellite networks were considered expensive and low bandwidth. Lastly, different departments such as billing or maintenance wasn't able to check the status of oil pipeline directly. They had to rely on the SCADA to do the job. All these challenges led to the creation of MQTT. MQTT stands for MQ Telemetry Transport, which is an application layer protocol that runs on top of the TCP. MQTT was designed for connections between devices with limited resources and was created way back in 1999. MQTT is based on a publish subscribe framework, which is event-driven that enables messages to be pushed by MQTT clients. An event can be considered as any significant change in state or sensor outputs. During that time, there were 20 devices connected to one concentrator. The concentrator represented the MQTT client. When a pressure sensor detected the pressure in the oil pipeline dropped suddenly, it would notify this event by sending out a message to the message broker. The message broker would then forward this message to the relevant subscriber, that is the maintenance department, which no longer needed to talk to SCADA in order to find out the pressure status of the pipeline. Let's move on to higher level overview of MQTT framework. The MQTT framework consists of the following major elements, namely MQTT client, MQTT broker, and MQTT topic. MQTT client refers to any hardware device that runs MQTT libraries or application. For example, a Raspberry Pi with a temperature sensor. If there's a change in temperature detected by the temperature sensor, then the Raspberry Pi will send out a message to the MQTT broker. MQTT client can be either become a publisher, or a subscriber, or both. The next element is MQTT broker, which refers to any hardware device with built-in broker software. A perfect example is the Antaira industrial cellular gateway, which has Mosquito installed. The MQTT broker is responsible for receiving messages from publishers and deciding who is interested based on the topics and sending messages with the matching topic to subscribers. The last element is MQTT topic, which refers to a string of words consists of one or more topic labels and is separated by a / similar to the syntax of a website address. For example, a temperature sensor will publish the current temperature value of 35 degrees Celsius to the topic of home kitchen temperature, which will be sent out to the MQTT broker. Since the message must include an MQTT topic, therefore the MQTT broker will forward the message to any interested client, such as an air conditioner that may turn on and off AC automatically based on the temperature received from the temperature sensor. Before the publisher publishes a message to an MQTT topic, the publisher initiates a connection by sending a connect message to the MQTT broker. The MQTT broker responds to the connect message with a connect acknowledgement message. Once the connection is established, the publisher can publish a message to an MQTT topic. The MQTT broker keeps the connection open until the publisher sends a disconnect message. The same principle applies to the subscriber. A connection requires to be established before the subscriber can subscribe a topic from the MQTT broker. The publisher and the subscriber don't need to know the presence of each other because they only need to communicate with the MQTT broker. Let's look at some primary benefits of MQTT. Here are some benefits of using MQTT. Decoupled design is useful in a scenario where we have limited network bandwidth, since publishers and subscribers don't need to run simultaneously. The other benefit is reliability, which offers 3 different quality of service levels. When the quality of service level is set to 0, the publisher sends the message only once, and the MQTT broker doesn't acknowledge that message is received. There's no guarantee that the MQTT broker has received that message sent from the publisher. When the quality of service level is set to 1, the MQTT broker sends an acknowledgement message back to the publisher after receiving a message sent from the publisher. If the publisher doesn't receive that acknowledgement message, it will resend that original message. When the quality of service level is set to 2, it guarantees that the message arrives at the broker exactly once, because quality of service 2 involves several control messages between the publisher and the MQTT broker. The delivery overhead can significantly increase. Therefore, quality of service 2 is the highest quality of service and is useful when message loss and duplication are not acceptable.